When we think of ancient wonders, our minds often jump straight to the Great Pyramids or the towering Colosseum. We picture grand temples and mighty fortresses, don't we? But what about the structures that made life in those bustling cities possible in the first place? I'm talking about aqueducts, the unsung heroes of the ancient world. These weren't just simple ditches, they were incredible feats of engineering. They were the lifelines that carried fresh, clean water for drinking, bathing and farming. Without them, the grand cities of Rome, Constantinople and many others simply couldn't have existed on the scale they did. They are true forgotten wonders hiding in plain sight. The sheer genius behind these aqueducts can be easily overlooked. Imagine a time without modern power tools, without laser levels, without computer-aided design. Everything had to be done by hand, eye and sheer brain power. The engineers of the past had to figure out how to get water to flow gently downhill for miles and miles. A slope too steep and the water would gush and erode the channel. A slope too gentle and the water would stagnate and become undrinkable. It was a delicate balancing act, a colossal puzzle solved with the most basic of tools and an extraordinary understanding of physics and the natural landscape. Think about what a city needs to thrive. It needs people, it needs food, and most importantly, it needs water, lots of it. Before aqueducts, settlements were completely tied to the nearest river or spring. This limited how big they could grow and where they could even be built. Aqueducts changed everything. They freed civilizations from the tyranny of geography. Suddenly you could build a city on a strategic hill, far from a major river, and still have all the fresh water you could possibly need. This innovation allowed populations to boom and cities to transform into sprawling metropolises that became the centers of vast empires. The impact on daily life was absolutely massive. It wasn't just about having a drink. This constant supply of water powered magnificent public baths, which were central to Roman social life. It flushed away waste through complex sewer systems, improving public health in a way that was unheard of for the time. It irrigated farms, ensuring a stable food supply for the growing population. And it filled the basins of ornate public fountains, which were not just decorations, but also symbols of the city's wealth and the emperor's generosity. The aqueduct was the beating heart of the city, pumping life through its veins. So how on earth did they do it? The fundamental principle was beautifully simple: gravity. The entire system was designed as a gentle, continuous slope. The source of the water, usually a spring or a mountain lake, had to be higher than the final destination in the city. The surveyors, or grammatici as the Romans called them, were absolute masters of their craft. They would use simple but effective tools like a chorobates, a long wooden plank with a water level carved into it, to painstakingly measure the gradient over many miles. It was slow, meticulous work, requiring an incredible amount of patience and precision. Building these channels across a varied landscape presented enormous challenges. When the aqueduct encountered a valley or a dip in the terrain, the engineers couldn't just have the water flow downhill and then back up again. That's not how gravity works. Their solution was the iconic arched bridge we all recognize. These magnificent structures carried the water channel high above the valley floor, maintaining that all-important gentle slope. They built these arches using wooden scaffolding, placing precisely cut stones or bricks to form the elegant curves. Once the final keystone was in place at the top of the arch, the structure could support itself and the scaffolding was removed. Sometimes a mountain stood in the way. Instead of going around it, which could add miles to the route, the engineers often chose to go straight through it. They would dig tunnels, sometimes for several miles, right through solid rock. This was incredibly dangerous and difficult work, often done by slaves or soldiers. They would use fire and water to crack the rock, lighting a huge fire against the rock face and then dousing it with cold water to make it brittle. Then with hammers and chisels they would slowly chip their way through the mountain, working by the dim light of oil lamps. It's a testament to their sheer determination. The water didn't just flow in an open channel, exposed to the elements. For most of their length, the aqueducts were actually underground conduits or covered trenches. This was a clever bit of design. It protected the water from contamination by dirt, leaves and animals, ensuring it arrived in the city clean and fresh. It also prevented evaporation, which was vital in hot Mediterranean climates. The channels themselves were often lined with a special waterproof cement called opus signinum, made from mixing lime, sand, and crushed pottery. This concrete-like material was incredibly durable, and it's a key reason why so many of these structures have survived for 2 millennia. While many ancient cultures built water channels, it was the Romans who truly perfected the aqueduct on a massive scale. Their empire was built on order, logistics, and engineering, and their water systems were a perfect example of this. The city of Rome itself was supplied by 11 major aqueducts by the 3rd century AD, providing over 1 million cubic meters of water every single day. That's enough to fill 400 Olympic-sized swimming pools. This unprecedented supply of water is what allowed Rome to grow into the first city in history with a population of over 1 million people. It was a statement of power and technological supremacy. One of the most famous and best preserved examples is the Pont du Gard in southern France. It's absolutely breathtaking. It was built in the 1st century AD to carry water to the city of Nîmes. The bridge itself spans the Gardon River, standing nearly 50 meters high with 3 tiers of magnificent arches. When you stand beneath it and look up, you can't help but be amazed. It was constructed without any mortar for its main structure. The massive stone blocks, some weighing up to 6 tons, were cut so precisely that they fit together perfectly. It's a masterpiece of both engineering and art, a true giant of the ancient world. Another incredible survivor is the Aqueduct of Segovia in Spain. This thing is just jaw-dropping. It runs right through the center of the modern city, a colossal structure of granite blocks. What's amazing about Segovia is that, like the Pont du Gard, its 167 arches were built with unmortared, perfectly fitted blocks. It delivered water to the city for nearly 1,900 years, only being replaced in the 20th century. To see it today, towering over cars and cafes, is a powerful reminder of the skill and ambition of its Roman builders. It doesn't just cross a river, it marches across the city with an incredible sense of purpose and permanence. But the Romans weren't the only ones. We find clever water systems all over the ancient world. In the Middle East, the Persians built qanats, which were gently sloping underground tunnels that tapped into groundwater and brought it to the surface without the need for pumping. In South America, the Nazca people created a system of underground aqueducts known as puquios, which are still in use today. Each civilization faced the same problem, the need for water, and each came up with its own ingenious solution based on the landscape and materials available. It shows a universal human drive to innovate and master our environment. It's easy to think of these ancient structures as relics, just tourist attractions from a bygone era. But their legacy is all around us. The fundamental principles of the Roman aqueduct, using gravity to move water over long distances through carefully graded channels, are still at the heart of many modern water supply systems. Today we use massive pipes and tunnels instead of stone channels, and we have powerful pumps to help. But the core idea of a large-scale water distribution network owes a huge debt to those ancient engineers. They wrote the first chapter in the story of municipal water management. Think about the materials they used. The Romans were masters of concrete. Their special blend, sometimes using volcanic ash, was incredibly strong and durable. It could even set underwater. This technological breakthrough allowed them to build bigger, stronger, and faster than ever before. Modern engineers are still studying Roman concrete to understand the secrets of its longevity. In an age where we are looking for more sustainable building materials, there are valuable lessons to be learned from the durability and resilience of these 2,000-year-old structures. They literally built for the ages, and we could learn a thing or two from that. The very concept of public health being a civic responsibility was advanced by the aqueducts. By providing clean water for drinking and washing, and by flushing away waste, the Romans created healthier cities. This link between clean water, sanitation, and public health is now a cornerstone of modern urban planning and international development goals. When organizations work to bring clean water to communities around the world today, they are continuing a legacy that began with those Roman engineers and their ambitious projects. They understood that water was more than a commodity. It was the foundation of a healthy and prosperous society. So, the next time you see a picture of a Roman aqueduct, don't just see a beautiful ruin. See it for what it truly is. A symbol of human ingenuity, a triumph of engineering, and a revolutionary piece of public infrastructure. These structures remind us that the challenges we face today, providing for large populations, managing resources, and building sustainable infrastructure, are not new. The aqueducts are a powerful connection to our past, proving that with bold thinking and a deep understanding of the world around us, we can achieve truly amazing things. Their story isn't over, it continues to flow right into our modern world.